Welcome back to part 3 of this video series about setting up Oracle, adding roles and objects and users to the database schema. And then finally now we want to set up some kind of application security. So in this video, we're going to be looking at a package that you can find in the sys schema called dbms_crypto. And that will allow you to do encryption and decryption. And it also have other types of functionalities like hashing and so forth. So in this video, I want to take a look at that in more detail. Also in this video, I want to use ASP Core Web API to test the connection to Oracle and see if I can call these different types of functions and get the results back to the web API. So it's part of a bigger picture. So if you have a web application, for example, that's going to connect to Oracle and verify users and run packages, etc. You want to test it out on a web basis, so to speak, with that web application user we generated in the previous video. So kick back and hopefully you enjoyed this video as well. Before we continue, I just want to show you something that might give you an issue. Now, if you look here, I got my users set up. So if I go here to this web application and try to load it, notice I'm getting a network adapter error. So I could not establish that connection. Now, if you get something like that, first place you might want to go and check, go into your services, like here. You can just go into Windows and search for services, or you can just, type it in here or what have you, like services like this, and then you open it that way. But once you get into the services, what you want to check for is you click somewhere, and I hit O for Oracle, and now I'm down further down. Now, when I look at this, it tells me that this is running and the XE service is running and the writer here is running. But what is not running is this listener. So what I want to try to fix that is I'm going to start that listener and then I want to go back and try to connect again. So let's see what happens this time. So now I'm going to go and open it up again and I'm still getting an error here. So it might take a second. I don't know. Let me see. Yeah, so now it's working, as you can see. Now it opened up. It took a second before it actually comes through. So now you can see the web application and everything is open. So that's something you might want to keep an eye on if you're getting some network issues when you try to log in. Okay, so let's start looking at that DBMS crypto package. And the place you want to go to find this package is in the actual sys schema, which I call Oracle 21 CXE. So when I go there and I open that schema up, and I showed you this in part 2 of this video series, but if you scroll down to DBMS crypto and look at the actual, right here somewhere, there it is. So notice that all these system packages, you can only see the spec, meaning the header or the actual, where you list the functions and constants, etc. here, as you can see. Now, one thing I want to point out is, and I'll show you this in a Word document where I extracted out information about this package, and hopefully that will make more sense. But a lot of times, if you look at these functions, the functions are going to expect a specific input type for the source and the keys, etc. Notice they expect a raw, okay? So we're dealing with varchars here. Now, this package also allows you to work with large objects like clobs and so forth. So if you look here, notice that, for example, for the encryption function, it expects a raw input, and it's the key is also expected to be raw. But notice this procedure for encrypt. That expects a blob, a binary large object. And you can see here, there's another one here that has a clob. So typically what you see is that the functions will deal with the smaller data types, and the procedure will deal with the large objects, as you can see here in this crypto package. So that's one thing I wanted to highlight. All right, so let me just kind of show you the package, how I refer to it, and then we'll look at the details of the expectations for this package. Like I said, I prepared a Word document that will lay this out for you. So I think it might be more meaningful if I first show you the code and then we'll go back into Word document so you can better relate to what I'm talking about. It might be a little hard to understand otherwise. So we're going to this demo security package here. That's the one that holds all the DBMS crypto functions. So if you look here, there's 4 of these. The first one I have listed here is the encrypt data. And I'm passing in a user ID, and I'm passing in a user key, and I'm also passing in a text to encrypt, okay? So those are the parameters that I'm passing in. And if you remember from previous video, and if you need more explanation about this, please visit previous videos in this series, because I won't repeat myself too much here. But I set up an error handling routine that is basically a utility package here that actually, when something goes wrong when you run this, it will go to the exception handler. And down in each one of these functions that I created, there's an exception. And I have my own exception that I create, or you can use the built-in Oracle catch-all one like this, when others. That means everything else. If you want to create your own, you want to use this number system over 20,000. That would be a custom number you can use to raise like an application error if you want to do that. So the way to call that exception handler, if you look at it here, I am selecting a master key from a security master key table. And there's an object that's stuck into that table. So I'll show you that in 1 second. And then I'm also checking to see if the user that calls this function exists. And those users should be located in this demo security table. And I'm passing in the user ID. And if you remember from previous video, I made a unique constraint in that table that was based on the user, and it was based on whether the user is active. So those are unique constraints in that table. So if we look in that table right now, and I go to demo security, you can see that the data in here is referring only to the demo user. So that's the only one active here, as you can see. So in other words, the uniqueness of this table will be this field combined with this field. So this demo could exist twice, but it will not be a Y. It would be an N if he is, because meaning is you have, and this is just one way of doing it, obviously. You could say that, hey, you can only have one user and you either have to toggle between yes and no here. That's up to you. I leave that up to you. Now, if you create tables that you necessarily don't want to delete records from, then this might be a good one of doing, because you have the timestamps when it was created, etc. And when you update it, you will have in the modified section here. So meaning if you toggle this to a no, you'll still have that timestamp, but you won't see basically when it happened, etc. You can see that the modified date, etc. But if you want to see everything, you could just keep inserting here and then just toggle this flag. That's up to you. I leave that up to you. All right, in any event, this is the security table. So there is a field for encrypted text, and there's for password, and there's for user ID and active field. And these are just audit columns, I call them. That is in every table of mine. So basically, in that package, we're going to be able to create that user or update that user. And an update might happen if you put in some encrypted text or you change your password, what have you. And then the decryption would be retrieving encrypted text from this field here for this demo user, and then making it into plain text again. So that would be the purpose of the decrypt data. I don't let you pass in data to decrypt. It will read from this table and grab the encrypted text and decrypt it for you. So that's the purpose of showing that particular routine. Then you have the create update user, which will actually insert this record if it doesn't exist for a new user, okay? Or if it does exist, it will update it. So you could potentially update this or the password will have it. And then finally, you have the verify user, which will basically grab this password. And this password is what's called a hash. It's a hash. It's not encryption. It's a one-way type of encryption. It's called a hashing code. And meaning that you can't decrypt it. You can only run it into this format and then have somebody pass you in a password and then create another hash and compare these two And if they match, okay, then it's the correct password. If it doesn't match, then it's a no-go, meaning you won't let that user continue. So that's what's called a hash. All right, so these are the functions we're talking about. So let's go and kind of look at them quickly. So here's the encrypt data, passing in the user ID, the user key, and then the text to encrypt. Now, in this code here, there's different ways of doing this. You can do plain vanilla encryption, but you can also make it even more secure and demand that the user pass you a key with it, so you know that that encryption is not available to others, because you need that special key in addition to what you want to encrypt in order for this to work. And you can combine the encryption thing and the key to make that encryption a lot more secure. So that's one way you can do this. And as you can see here, here's the error handling parameters. That's going to be basically, if something goes wrong here, it will kick you down to the exception here. And unless it's this type of exception, it will go here. And in this one, it will load the procedure step, meaning it will find out information about what procedure you're in, what line number failed, and so forth. And it will put it into this demo error log table here. It will insert a new record there, and it will tell you what the error was, which procedure produced it, or function in this case, and what line it happened on. So you can backtrack and try to figure out what happened here. Why did it go wrong? And it's good for when you're in a development environment, primarily, I think. But even in production, this is very helpful, because when somebody does something and you go into this table and you double check and see what's going on, and you can troubleshoot some errors you didn't expect to be there, or that happened later after you deployed your own solution here. So that's a good thing to have. All right, so you can see here, it takes that and it calls this package, and then it logs the error through this procedure. And you might recall that we looked at this before, and here is the package, here is the procedure that's gonna, and you're passing in those variables from your exception handler, and it's gonna insert into this error log. So that's what happened here. Okay, so that's what this piece is doing, and then it raises an application error. So in case you call this from the web, then you're getting this custom code back, and it will tell you what went wrong. And in case you wonder about this, just go to the header here, sorry, this one, and then you can see here. I'm kind of explaining it here to you, so just read this part, and you should be able to understand what's going on. So I gave you a little extra information here about what these packages are doing. All right, so that's the encryption function. And if you look a little closer to it, you can see that the steps I'm taking here is I'm setting up the algorithm here. And we'll touch on this when I get into the Word document. But you basically have an encryption algorithm. And this is a 128-byte type of encryption. There's also something called chaining and padding, and I'll talk about that in a little bit. But here we set up the algorithm. And if you recall, I said that the inputs to this function for the DBMS crypto is going to be of type raw. So here you can see I'm creating two variables for the key, the encryption key, and the encryption text, basically. So I'm going to load this variable with the text to encrypt. So what happens next here, I'm going to select the master key. And again, this is a matter of opinion, because how secure is secure. So wherever you want to put this master key, like any key, key to your house, key to your car, how secure do you want to make it? Do you want to hide it somewhere? Do you want to put it in somebody else's care? Or what do you want to do? You want to put it offline or in a table, whatever have you. So you got to make those decisions. But in this case, just for demonstration purposes, I created a master key as part of my script for the previous video, and I just made it up. And I made it into 16 characters, and then I loaded it into this table here. And the master key, security master key, belongs to the demo security. So in other words, it's this demo security. Okay, so it belongs here. And if you look at the security master, it's in plain vanilla text there, demo underscore master underscore key one. That's and it belongs to this schema, the security of this schema. So I just call it demo security. Again, I leave it up to you how you want to handle this and how you want to put it together. But this is just for demonstration. So get the key from the table. So that's the first thing I do, and I load it into this variable, this varchar 2000 here. And then I go and see if there is a user. So if I find a user, meaning this becomes 1, the user exists because I'm passing the user ID, and it has to be active because that's the kind of way I set it up. And if the row count is 0, then I raise the user do not exist, meaning I don't find them. Therefore, I will run down to this exception handler, and I will raise an application error. And this is a custom application error for this exception. If he exists, I will continue. And this is where I create my encrypt key. So I'm going to generate a new encryption key. And that's of type raw because this function is accepting raw. But if it's a large object or a blob, then you use the procedures, okay? The DBMS crypto procedure. Now, if you look here, this one is going to use another package called UTL raw. And we'll discuss that in a little bit. And it's going to basically combine the user key with the security master key. So you're getting a key that any user who logs in here can have in possession. And then the master key will be combined with that one. So it's more secure. It's a row by row type of encryption. So that will be unique. So in case he loses this key, the next guy in that table, then with security, will still be okay because he will have his own key. Now, if you lose the master key, on the other hand, that's a different problem. So that's what I'm saying. You need to figure out what's the best way of maintaining these keys in a secure way. Whether you save it off to some off-site place in case you lose it, you can recover it that way, or some, I don't know. Any way you can think of. That's how it works. But in this case, I'm combining the two, master key and the user key. And this will only be workable for that user. So it's per row kind of encryption here. Here is the variable that's going to hold the encryption after I load it. And that's of type raw, as you can see up here. And in order to encrypt it here, you'll have to convert this text into raw. And Oracle has these packages, the UTL _ I18N string to raw function, that you can take that in. And also the character set that it expects is this. Okay, so this is the character set. Now your database may or may not have this one. And if it doesn't, you have to convert it into that. And there is an example in the code here that does that. And I'll show you in a second. And here's the algorithm from above. That's the one I set up here, algorithm number, this one here. So it contains of the algorithm, the encryption algorithm, and then the chaining and the padding. And we'll talk about that in a second here. And then it goes to town and it creates this encrypted text. And then I just dump it out to the DBMS output so I can actually see what it looks like. But then I say, hey, if that user existed, the row count for that user, you found the user, then update that demo security table with the encrypted text for that particular user that is active. And then I just set up a message. Okay, it's been updated. So here I'm checking to see if it actually did it. And if it did it, I commit the changes. And then I return that message. So record is updated. Otherwise, I'm rolling it back and I'm returning a null. So nothing happened, kind of. And that's the encryption. Then I have decrypt data that basically does the opposite. But in this case, what I do is you still set up the algorithm like this. You still create your raw variables, but in this case, it's a decrypted one and the decrypted key. Same stuff. I'm getting the master key. I'm checking to see if the user exists. If not, raise an exception for that user. And then what I do is, if the user exists, I want to decrypt the existing text that is stored in that encrypted field. This one, if there's a text in here, that's the one I want to decrypt if there is text in here. So that's what I'm doing here. I'm loading that in here. Now, one more thing you might want to do here that I didn't do, I see now, which was kind of stupid. you should check and see if it's null. And if it's null, you basically shouldn't go ahead with the decryption because it's nothing to read there. So if that field is null, you could set up some NVL kind of thing here and check and see if it follows, NVL is NA or something. And if so, you don't want to continue. So you could check that variable and see if it's equal to NA. If so, don't continue, that kind of stuff. I didn't do that. It was kind of silly. Anyway, here I'm doing a hex to raw. I'm converting that to raw. And then and these methods are just the methods you have to use in order to convert this back and forth to get in the right format. And then I'm using the combined key again, using this utility raw package. And this is going to be adding the master key to the user key, as you can see here. And then you decrypt the values right here, as you can see here. So you basically have to get in the right format before you can decrypt or encrypt. And that's a little, it's not as intuitive as you always would think. So that's why it helps to some extent. And then I'm returning it because I want to return it in clear text. I use this UTL I18N package, and I do a raw to char for this text. And that returns it in clear text. And then it's just exception handlers from there. All right, now create and update user, passing in a user ID and password. And again, very similar stuff, setting up some local variables, the master key raw. Okay, so again, it's a little different again. Again, I'll leave it up to you to dissect this code a little more in detail. But it works, so that's all I care about. Here you get the master key. Here you check to see if the user exists. Here you convert it to raw. So anyways, we're going to convert this, the raw password, as the source. We're going to run the crypto for the hash mat MD5. And the key is going to be the security master key raw that we're going to pass in. So it requires this format here. And then we check to see if it's active, and then we go ahead and we insert or we update depending what the scenario is. Because in this case, if he exists, we update. If he doesn't exist, we insert. So now you could have used maybe a merge statement here, but it makes it a little more complex to write the logic of it. All right, so there's nothing really new here. And then finally, for verifying user, what you want to do is you basically want to have the user pass in its password and its user ID. And then you want to query the password from the demo security table for that user. And you want to compare the two. And if they are the same, then he's okay. Then you give him a yes flag back. And if he's not matched, then it's a no. So that's what you pass there. So here I'm declaring some variables. Select the master key again. Check the user exists. If not, exception. And then I'm selecting the password into this variable for that user ID. And then I convert it to raw. So the security master key raw. And then the raw password in. I convert the password they passed in here to the right character set. And then what I do is I encrypt I hash the password, so to speak, with this security master key. And then what you do is you compare the password that sits in the database with the one that you just generated that user passed in. And then you compare the two and you say, hey, are they the same? If so, it's a match, return a Y. Now, you probably want to take this out when you actually have this working. So that there's no point of having these written out to the panel every time. So that's basically what this one does. Pass a password in, check it with the database. If they both match, then it's a match. You give it a Y back. If not, it's a no. All right, so that's the 4 functions in here. So now let's take a look at how we can actually run this stuff and compare it. All right, so to test this stuff, what I want to do is I want to test it from this web application user. So let's open him up, and let's open up a web application. Another thing I want to do is I want to activate the DBMS output so we can actually see it. So I'll add a connection to the web application, say OK, And let's make the buffer. I always add another one. Click down here, get rid of that. So now that one is ready. And let's also dock it so it doesn't disappear on us all the time. All right, so what I want to do now is I want to basically run this. So how can I do that here? Well, the easiest way, I think, is go into demo, go to the packages, and let's create a new user first. So let's open that guy up. And let's just say run. And then what I do is I copy. I'm going to create a new user. I simply copy this text here like this. Control C. Go back into my query window for that web user. And then in here, I want to create a new one. So because it doesn't exist, I'm just going to call him web, just for the heck of it. Let's call him web. And then what I want to do, actually, let's call him web application. But that will match the actual user that we're logged in as here. The password I want to give him, I'm just going to call him web $1 or something like that. Let's make it all caps. All right, so that should be easy enough to remember. So I'm gonna basically remove this piece, and I want to remove this piece. I don't need these returns, but I want to write it out and see what it looks like. So let's go ahead and run this now. And it gave me an error, and that error is why. Okay, so I call this directly like this, but because I'm running in my user schema, it doesn't recognize it. So in order for that to recognize it, I have to prefix it with the actual user, the schema in this case. So I'm going to call it demo like this, and the package is called demo security package, and the function is called create update user. So let's try run it again and see if it actually does it. So I'm running it, and it completed, and it says record inserted. So it looks like it works. So let's go and take a look, and let's refresh, and sure enough, there's web application, and here is the password. So that's the hash password that I now put into this database. Now I want to test and see if I can find it. So let's do it two ways. So the user ID is this. So let's make sure that one works. So I'm going to put that in here. Okay, but the passport, let's make it not match. So I'm going to say PSW1 or something, right? So that's the password I'm trying to pass in. So now I'm going to run that and see what happens. So let's highlight that and run it. Okay, and I got an error again because I didn't learn from my previous mistake. So I'm going to have to prefix it with demo like this. Okay, let's try it again. Let's clean it out and then run it again. Okay, so here we go. Okay, record updated. All right, so, oh, I'm sorry. I ran the same one again, which is not what I want to do. But okay, it showed you that now I updated it the first time I created it. So let's go and look at the table now. And as you can see, it changed this password now because it's PSW1, right? So it's a little different. So what I want to do now is, let's just try to leave. I don't think I have to change any of this. So let me just type verify user. See if that works. I don't know. Maybe the same parameters, I think. So in this case, I'm going to try just PSW2. Let's see what happens. So I'm going to try to run this now and see if it actually works. And it came back with, here is the, because I'm typing it out in the package, which is just so I could see it, but you want to remove this because it doesn't show up here. But here's the password 1. And here you can see here's password 2 hashing. So it's different. So there's no match found, and I returned a no. If I want to match it, I'll have to do the same thing. So I change it to pass 1 here. And let's clean it. And let's try to run it one more time now. They should match now. Let's take a look. And sure enough, now you can see here, they both match up here. And therefore it returns a yes and is a match. So that's how you can use hashing for your passwords and have them be verified through a function like that for the password. And of course, if they get verified, you can just take that and have them have access to other things. You know, maybe they query some table, and you do this as part of the check. You run this code to see if they're actually allowed to do so. So anyways, that's the create user, update user, and also verify user. And we also looked at the, now what we want to do is we want to look at the encryption and decryption. So let's basically go to encrypt first, maybe. Let's run, and let's grab that code. Control C, back to our user, Control V. Let's get rid of this and this. And then what we want to do is we want to pass in web application. So here's that user we created. Now it's going to expect you to give a user key in. And that key, we'll talk about how to generate that key. But right now I'm just going to type in a key. I'm going to make this up basically. I'm going to say maybe web key. Okay, that's 1, 2, 3, 4, 5, 6, 7, 8 characters. So let's go 1, 2, 3, 4, 5, 6, 7, 8. All right. So now I got like 16 character key here. And then the text I want to encrypt is going to be, all right, so here I got, wow, how cool is encryption. So now we're going to test this and see if we can actually get it to work. So I'm going to run it. And it gave me an error again because I never learned. Demo. Okay, let's run it again. And it says it succeeded. And here is the encryption right there. So it was updated. The record was updated by adding that to this field. So let's take a look. So here is the web application. So I expect something to show up here. So let's refresh. And there it is. So now it showed up. All right. So the next thing we want to do is we want to decrypt this and see if we can bring it back into clear text. So in order to do that, I think I need slightly different codes. So let me copy that. And Control A, Control C, cancel. Back here, Control A, delete. Control V, and let's get rid of this. And let's, oops. All right, so now what we want to pass in is the same guy. Application. And what we also want to do now is we have to pass that user key. So if you recall, I just made it up on the fly. I called it what? Web key underscore. And then I did 1, 2, 3, 4, 5, 6, 7, and 8, right? But let's do a 9 and see what happens. So now I did it, but I used the last digit is wrong. So let me see what it does and what it gives me now. All right, so let me clear this and let's run it and see what happens. Okay, so it gave me an error here. Okay, again, never learn. Oh, okay, so run. All right, so it gave me a error. Error on line 213. Okay, so I couldn't do it. All right. So I don't think it has put anything into our error log yet. Let me just check to make sure. Oh, look at this. I did it. So we got a record. Notice I came from the decrypt data, and here is the step that it did. Let's open that and see what it says. It was line 67, and it was also, it gives you some other line numbers here because the crypto is being called from this one. So inside this package, 185, on line 185, it failed. It tells me, that's what it tells me here, it failed on. So it did log the record in here. So that came from the web application, is the user. And here's the actual error message. So you can read that as well to see what it actually It returned an error, so that doesn't really tell you much. It tells you the error code it produced. So what you can do is, it told me that it was line 185 in this package. So when you go to line 185 in that package, and you scroll down here, and 185 should be right here. So it failed on this particular function. So the error log comes in handy when you want to kind of troubleshoot and figure out where did it go wrong. It tells you kind of where it had problems running it, and it put it into that table. So that's a good thing to have. So that was nice, because now we have at least some way of showing the error log as well. What I want to do this time, I want to make the right call, and I'm going to make it an 8. And hopefully now it should return the clear text. So let's run it again and see what happens. I'm running it, and sure enough, wow, how cool is encryption? So it decrypted that text from that table. So that's pretty cool. So that's a little bit about the functions for create, update user, decrypt data, encrypt data, and verify user. So next thing I want to show you is just a little bit more details how to construct these. I won't spend too much on it, but I'll point out a few things, and I have it in a Word document. And all this code and all the scripts and everything, and this Word document, what have you, I'm going to put that out on my GitHub repository for this video series, so you can take a look at it in more detail that way. Otherwise, if I keep going through every little detail here, the videos will be very, very long, and you probably get bored. But let me just highlight a few things about these encrypt and decrypt and the user creation and verify user with these hash passwords. Okay, so here is my Word document. So I'm writing up this DBMS crypto. And actually, to be totally honest with you, what you see here is a summary of this package, what it does. And my good friend, Bing Chat, wrote me this summary. I asked him for, give me a summary of the DBMS crypto package in Oracle database 21C. And this is what it came back with. And as you can see, you can read this. And if you look at it, it has just a nice little summary. These tables are taken from the documentation for the 21C. And again, I listed the sources down at the bottom here. So you can click into these links to find out more about it, the DBMS crypto package. And also some of the stuff that I used here for this document and so forth to figure out stuff was Microsoft Bing Chat. So, it comes in very handy. You can do it a couple of ways. You can open up Bing like this. You can click on here sidebar and do a chat this way. Or, like I like to do because I want more real estate, I simply go to Bing chat like this. So it's www.bing.com. And then you start asking questions down here. And it's very helpful if you're going to write some good prompts and get some good answers back. There's a couple of tricks you probably want to use. You want to use things like show me step by step. That's a good way of saying it. Or here is an example of what I'm looking for. So you kind of give the AI a little bit idea of the output you expect to see. If you do that, it takes a little longer, but it gives you much better results. And also you can say more creative, more balanced, and more precise, depending on what you're looking for. So take advantage of this tool. You can see here there's my stuff. And, I'm asking for code examples. Tell me how to do this. Stuff like you normally go to Stack Overflow to find out about. It's much quicker here, but be very careful because, it could be hallucinating and give you some stuff that doesn't have anything to do with it. So you should always double check everything. You should have some basic understanding of what you expect to see. So anyways, use those tools because they come in handy. And here is the Word document where I list all this stuff. And I'm also talking about these different packages that I used. So let's just go very quickly through it. So this is the summary. Here is the DBMS crypto overview. So if you can see here, you can do these algorithms. You can see here, the one we're using is the AES 128. There's paddings, and there's chaining, and there's also keying for like hashing. And there's this MAC thing. So we're using some of these, and I highlighted in this document what I'm using in my code. So if you look down here, you can use the raw, plop, and binary large object types inside this crypto package. Remember the procedures, those are the functions. Here are some of the data types. Again, we just went through this. Here are the algorithms. The one we used was this one. And it's an advanced encryption standard. And it's using 128-bit key size. All right, so that's how that one algorithm works. Now, what I'm doing here is, when you use this, what kind of keys should you create? Well, I write a little example for you here. So if you look, if it's a 128 AES key, that's 128 bits. And therefore, if you look that the most computers use an 8-bit word size, so each byte is 8 bits long, so you can calculate the required key length in bytes by dividing the number of bits by 8. So in our case, we have 128 bits. You divide on 8 bits per byte, so you're getting 16 bytes. So a suitable key for this kind of algorithm would be a 16-character long string. And here's an example of how you create that one. So that's how you can come up with the key. And of course, if it's a 192 or 256, divided on 8, then you're getting the different sizes. So here's one for 256. You need a key that is 32 characters long, etc. So that's how you can come up with the keys. There's something called chaining. The chaining works something like this. After you dividing the data into chunks, there needs to be a way of connecting them. So this process is called chaining, and the security of this encryption system depends on how the chunks are connected and encrypted. So there's different chaining methods that are being used, and the one we're using is this chain CBC, okay? So you can see that's the one we're using, the cipher block chaining method. So that's the chaining we're using in our algorithm. And then you have padding. So the padding is, and you can see I wrote a little small summaries about what padding and chaining is. So just read that. But when you encrypt the data, it's typically divided into 8-byte chunks, and each chunk is encrypted separately. However, the length of the data might not always be in a multiple of 8. And if not, you might have to pad it. So that's what this padding comes into play here. And there are also some restrictions when you do the crypto. For example, if you have the type varchar here, you need to convert it into this character set, and it has to be of type raw. So that's what I'm saying down here. And this is how you convert it into the raw. UTLA, okay, this UTLA I18N package can be used to convert string to raw, and as well as you can cast to raw. However, the string to raw will do two things. The cast will only do one thing. So you should use this string to raw. And that's kind of what I'm laying out here. So you can read that up on that here. Here's some exceptions you can run into. And here is like the encrypt and decrypt function are used to encrypt and decrypt raw data types. Data of type varchar2 must be converted to raw before you can use the functions in the DNS crypto to encrypt it. All right, here's hashing. So hashing is not reversible. We created it one way, like you saw we did when we created the password. And here are some of the hash functions that are being used. And the one we used was in combination with this message authentication code. So basically, it's the same as this hashing you see above here, but you provide a key. So it's extra protected. So here you can see it requires a secret key to verify the hash value. So it's more secure than just pure hashing. And here is part of the code that I did for the master key. And here, what you do is you convert the security master into this type here, as you can see. So I wrote down here what it actually does. So, and then finally, I just have a little bit about the different packages. Oracle naming packages. It looks kind of cryptic, doesn't it? UTL I18N. What it really means is that this is the global, additional globalization functionality for Oracle. And what happens is that this naming came as a result of internationalization. It starts with an I and it ends with an N. And then there's 18 characters in between. So that's how they named this thing. And finally then, what I want to do just very briefly now is I want to show you how you can call this code from the web. Okay, so I used Visual Studio 2022 and created a new project basically. And I used an ASP.NET Core Web API. So that's the one that I set it up with. You go next, and you basically step through this. So once you created that project, it looks something like this, and it has a controller section here, which is this one, and also I have this security folder, which basically holds the class that actually calls Oracle. So let me show you very quickly how this works, and then we'll just go through the code very run it so you can see. Here is how I'm setting up my connection in this app settings JSON file. Give it an alias, dbcon, and then the data source is here, localhost, port 1521, connect to the server. There is your XC portable database 1. Here's the user web application. Remember, we create that app. And here is the password. So that's just the connection string for logging into the Oracle database. Here is the security data that I'm basically querying for. And again, as you can see, it has the verify user code. It has the encrypt data. It has the decrypt data. And it has the create update user. So if you want to run, say, verify user, you create a reference to the package and the user. And notice I prefixed it here correctly with the schema demo dot. Here's the Oracle connection. And in order to create that connection, what I went and did, I added dependency to a package called Oracle Managed Data Access Core 3.21. And again, it's very simple to do. Go to NuGet, manage NuGet, go into browse, call Oracle manage, something like that, and it will look for it. And here you can see, here is the Oracle Managed Database for Core. So that's the one I downloaded here, 321. You can see it over here. So that's that package I use. All right, so once you got that installed here in your packages, you can call it, set a reference to that package. There it is, using statement, and then for the data, and there's the namespace I'm using, and simply these are just basic plain vanilla running a package in the code here. So you create a command object, pass in that package reference here, add the connection to it, create a command type or type stored procedure. Here you're creating a parameter that you want to return. But this will be the return variable. It's going to be in the form of actually it should not be clob. I mean, you can set a varchar2. It's not the ref cursor either. You can change this to a varchar2 because I think that's what we return regardless. So if you look at a varchar2, you can set it like that. Right now it's set for clob, but that's not necessarily correct. And here is the user in, ID, password in. So each of these functions has the correct parameters you need to pass in per what's in that package. Open a connection and execute a non-query because you're running a stored procedure. And here's the return value coming back. And it's just converted into a string, as you can see here. And it still sits in the Oracle clob. I don't know. I think this is an old code I just rewrote. I need to fix that. Anyways, so you can see encrypt data, decrypt data, create update user. And also as part of this framework here, I'm using a controller. And the controller is what calls this function, these functions. And if you look here, here is a routing for API controller. And I'm not going to get into how to create web APIs because that's something you can figure out. But basically, you have a controller and it's being substituted with a name. So here, for example, I'm using a get, and I gave it a name here for the routing. And here is what I'm passing in for this particular get statement. So this one is going to do the encrypt data. So you're creating this connection string here by calling that app JSON file for the connection string. And then you pass that into this function that's going to encrypt the data where we just showed. Verify user, encrypt data, decrypt data, and create update user. So there's a bunch of gets here, and they all have different signature, but I also gave it a name to distinguish them one from one another. So what happens is when I actually call this stuff, I will get a swashbuckle showing up. So as part of this project, you get a swashbuckle. So let me run that quick now. As you can see, it has the swashbuckle. So here is what I did was I combined two of these functions into one call here. And I had to do it because otherwise it wouldn't have worked. But you have the decrypt and the encrypt separately. And then you have the user, which has two basically. So when I click here now, the way I separated them was by passing in an operation type. So the operation type that I used, I have an if statement here. That if it is one type, in other words, if it's 0, when you pass in a 0, it's going to do the upsert user data. Otherwise, it's going to do the verify. So if it's a 1, it's a verify user. Otherwise, it's going to create to update the user with the 0. So that's how you got to pass it in on the front end. So let me go back to the front end here. I want to verify the user. So let's say it's web. And then the password we used was what? PSW1, I believe. And the operation type I'm interested in is 1 because remember, I combined those two to 0 is to create and update the user. 1 was verify. So let's see what happens now. I'm going to execute. And it came back and it said no. It didn't find that user. Okay? So let's try demo because I think it's demo $1. So let's try that and see if that will work. So let's change this. Demo, and I believe it's all uppercase. Demo $1. And we want to verify. So let's run that again and see if that gets some better results. Yep. So now it came back with a yes. That means it matched it. So that worked fine. One more thing we can do. I don't remember the password. Let's create an encryption for demo because we don't have one. So let's just go and encrypt something. Let's try it out. Let's do demo, and let's give it a user key. Now we make this up now. This is the first time around, so let's be careful. We call it demo key. Now, how many letters is that? 1, 2, 3, 4, 5, 6, 7, 8, 9. So I need to get to 16. I need what? 1, 2, 3, 4, 5, 6, 7, right? That should be 9, 10, 11, 12, 13, 14, 15, 16. All right. The text I want to encrypt is question mark. All right. So that's, all right, very creative. Let's run that and see what happens. So let me run that. And it did something. And it says record updated. So if we look back in the database now, it should have updated this stuff. And sure enough, here's the encrypted stuff it just did. Now let's decrypt it quick, and then we'll finish this video, and we're good to go. So let's go back, and we have the keys and everything. So I'm going to copy that key. Let's minimize, and now let's decrypt. Let's put in, try it out. Let's put in demo. And the key it expects was this key we just used here. Let's execute. Okay, and then there it is in clear text. Hello world, how are you? So it seems to be working fine. So that minimalistic amount of grants we gave to that web application user seems to be enough for it to actually work. So if you look at it again, if you don't remember, very few grants created for this web user, but yeah, we did create this, execute on this package, that again, because demo can execute on behalf of this web application user against the DBMS crypto package, we have demo run it for us on our behalf. So even with these very few grants, you can do a lot of work. And we also have a password that don't expire, as we saw in the previous video. So I really hope you like this series. And again, the videos tends to get very long when they have so much content in them. But I'll leave all of this material out there for you so you can read up on your own and try to follow it that way. And again, if you have any questions, let me know. I hope you like this video. I hope you like this video series. And, let's take it from there. Thank you so much for watching.